In this video, we are going to talk about the derivative of logarithmic function, okay? In college algebra, you have seen the logarithmic function, right? Do you remember? How do I write? If there is x equals to a to the y, how do I write this using log? You write y equals to log of the other side, and this base goes to the base, right? So the exponent equals to log of the other side, and the base goes to the base of the log. How do I read this? I read this as y equals to logarithm of x with base a. Logarithm of x with base a, okay? And also we saw that the log with base e is called natural log. Do you remember that? If the log has base 10, we call common logarithm. And the log with base e is called natural log. And we write log of x with base e as, do you remember how do I write that? You're right, that is ln x, okay? If there is a base e, you don't have to write that base. You just write, instead of log base e, we write ln. That means natural log, okay? Natural log of x. That's how you write, okay? And we see some of the properties of the log, and these properties are true for any base. So I wrote the formula for log base e, I wrote the formula for natural log, but these properties are true for any base. The base could be a, b, c, any number, okay, but that should be positive number, okay. So it says natural log of x plus natural log of y is equals to natural log of x times y. Meaning, what does that say? That says sum of the logs is equals to log of the product, okay? If you add two logs, then how do I combine those two into a single log? Is you write ln, a single log, and then x times y. By the way, here in this case, okay, so the x must be positive, and then a must be positive as well, okay? X must be positive, a must be positive as well, okay? Now, natural log of x minus natural log of y is equals to natural log of x divide y. So the difference of two log is basically log of the quotient. If there is natural log or log of x to the n, if there is ln x to the n, natural log of x to the n, that n you can bring that to the front and then write n times natural log of x. You can write that way, okay? And a to the x, the last property here is a to the x. Any base a to the x can be written as, the a must be positive, again a must be positive. A to the x can be written as e to the x natural log of a. If you want to change the base a as base e, then you can write e to the x ln a. What is e? E is an irrational number whose value is almost 2.7. Okay, by the way, here as I mentioned, a must be always positive, okay? A must be always positive. When a is positive, any exponent of a will be positive as well, right? So x will be positive by itself, but a needs to be positive, okay? So you can write a needs to be positive. That is must, okay? Now let us use these properties to do some of the examples. If there is ln root x squared plus 1, how can you write this? How can you simplify this? I can write this ln and then x squared plus 1 to the 1/2. I can write this that way, and then you can simplify this as 1/2. This power goes to the front, right? The exponent goes to the front, and then ln x squared plus 1. You can write that way. How about here? You can break this into the two logs, right? You can write ln 1 minus x and then minus ln 1 plus x. What did I do here? Because there is the quotient, this difference can be combined to quotient, and then quotient can be broken down into the difference. Similarly, the sum can be combined into product, but the product can be broken down into sums and so on, okay? So how about here? You can write this as ln, and then you can write x squared minus 1 over x to the 1/2, right? You can write 1/2 to the front and then write ln x squared minus 1 over x. Now how do you simplify that? Is you can write basically 1/2, write down bracket. This is quotient, right? So you can write ln x squared minus 1 minus ln x. That's it. Okay. So the last one is, there is the product, right? And then the second term on the product has the root. So how can you write that? You can write this as ln x plus ln root of x cubed minus 5. Okay. Now, what did I do here? There was product. So the product can be broken down into sums. That's what I did, sums there. And this can be written as ln x plus, if you write this in the exponent form, that 1/2 will be there, right? So you can write 1/2 and then ln x cubed minus 5. You see that? So what's going on here is, basically what we did there is, we wrote that as, this can be written as x cubed minus 5 to the 1/2, because the root means the exponent 1/2, and then that 1/2 went to the in front of the log, right? And then natural log, and then you write the remaining thing inside the parenthesis. Okay, guys? Okay. So one limit formula we will be using on this section is limit x tends to 0, natural log of 1 plus x to the 1 over x equals to 1. And how did I get that formula? We will prove this formula in section 5.6. Section 5.6. We will do this, okay? But for now, we will use this to find out the derivative of fx equals to natural log of x. Alright? So let us find out the derivative of natural log of x. So we want to, this is our main goal of this section, right? We want to find out the derivative of natural log of x. Do you remember the formula for the derivative? What is the formula for f prime of x? It is limit h tends to 0, f of x plus h minus fx divided by h. That is the formula, right? Let us plug in those values. What is that? Natural log of x plus h minus natural log of x over h. That is f of x plus h minus fx over h, right? So this is written as limit h tends to 0, right? So how can you combine those two logs? Natural log of x plus h over x divided by h. You see that? What did I do? It is natural log of, look at the property number 2. Natural log of x minus natural log of y. If you combine those two into a single log, you can write natural log of the first one divided by the second one, right? That's what I was doing. Natural log of x plus h minus natural log of x. So this can be simplified as natural log of 1 plus h over x. Do you understand this? Over h. What did I do here? Excuse me. So you can split that, right? X over x is 1 and then plus h over x. That's what I wrote here. Okay. Now I want to use that formula. Natural log of 1 plus x. But instead of x, we have h over x. So we need there 1 over that h over x, right? So what I want to do here is, I want to write like this. Limit h tends to 0. Okay. So what I want to do there is, I want to do this. Natural log of 1 plus h over x divided by, I want to do h over x times x. What did I do here? Because I want to match that. I want to write h, since I got h over x here inside the log, inside the parenthesis, I want to get exactly the same thing. And you will know why do I want to get that. You will know that later, okay? But for now, I want to, since there is just h in the denominator, I just divided by x and then multiplied by x, assuming that x is not equals to 0, okay? So what I want to do next is, I want to write this way. Limit h tends to 0, right? Can I write this as like x over h and then natural log 1 plus h over x divided by x? What did I do? Look at this. What is happening there is, there is natural log of x over h over x, right? So this x over h over x can be written as the top, whole the top thing, that thing times x over h, because this is like fraction of fractions, right? there is a numerator and this is the denominator. So if the denominator has the fraction, right? So if you want to write that in the product form, you can write the top fraction or whatever in the top times the reciprocal of the bottom. So the top times the reciprocal of the bottom is x over h. That's what that x over h I wrote to the in the front. Okay, of over x is as it is there. So what I want to do next is, so let me use different color there. So what I want to do next is, I want to write like this: natural log of 1 plus h over x to the x over h divide by x. Do you agree with this? What did I do? So the third property, this property says that if there is anything in the exponent, you can pull that down in front of the log, right? Similarly, if there is something in front of the log, you can go the other way too. If there is something in front of the log, you can move this to the exponent. Okay, that's what I did. There is something in front of the log, and then I moved that to the exponent. That's what I did. Okay, so what I want to do next is, the limit is h tends to 0, right? So the limit is basically h tends to 0. So what can I write this one then? So since this is h tends to 0, you can divide by x on both sides. What do you get? You can divide both sides by x. Okay, and then this can be written as into that form. Okay, let's do that. So this can be written as, let me pull that x out, because that x doesn't have h, so I can pull that out and then write the limit h tends to 0, natural log of 1 plus h over x to the x over h. So what did I do here? Here, what I did here is I'm trying to use the formula, okay? The limit h tends to 0, limit h tends to 0, okay? And then natural log of 1 plus something, 1 plus some quantity, and in the exponent, the reciprocal of that, okay? So look at this. Limit h tends to 0, natural log of 1 plus h over x. There is some quantity, and in the numerator, in the exponent, this has the reciprocal of that quantity, h over x. The opposite, the reciprocal of that is x over h. In that case, the limit will be 1. Is basically, this is 1, right? So what is left is 1 over x times 1. That is basically 1 over x. So what we can write here is basically derivative of natural log of x is basically 1 over x. Look at this. They are matching, right? The derivative of natural log of x is 1 over x. But if they don't match, how do you do that? You do 1 over u times the u prime, right? If there is natural log of u, but you are finding the derivative with respect to x, then it will be 1 over u, like that, right? The derivative of natural log is 1 over whatever there, and then times the derivative of that thing, times u prime. Okay, all right, let us do some more examples here. What I want to do here is, first I want to do this example. Find f prime of x if fx equals to natural log of 9x. What is fx? Fx is given as natural log of 9x. So it is, if it was just natural log of x, the answer would be 1 over x, but there is 9x. Basically this is u, right? So what is the derivative of u? So let's find out the f prime of x. That will be 1 over u times u prime. What is 1 over u? 1 over 9x times, what is the derivative of 9x? Just 9, right? So you cancel 9 and 9. Divide 9 is just 1. So it is 1 over x is the final answer. Okay, basically 1 over x is the final answer. By the way, this should be x to the 5. Okay, so y is given as x cubed times natural log of root under x to the 5. Okay, so how do I simplify this? I can simplify this as x to the 3rd times natural log of x to the 5 half, right? I want to write using exponent in the exponent form. Now because I can pull this exponent out to the front, right? So this can be written as x cubed times 5 over 2 natural log of x. See the formula number 3, that formula that I used, the property number 3. But this 5/2 you can pull that to the front, 5/2 and then x cubed times natural log of x. Now I want to find out y prime. This is like, you can think this as like f, this is like g. So this is just a constant, you can pull that constant out, right? So how do you write that? Is 5/2 is there now. So how much is this? This is the f times g, right? What is the derivative of f times g? It is f prime times g plus f times g prime, right? F prime is 3x squared times g is natural log of x plus f times g prime, right? X cubed times, what is g prime? 1 over x. Let's simplify that. This is 5/2, right? 3x squared times natural log of x plus this x cubed over x, right? You cancel one of those. So what do you get? You cancel that with the cube. So what is left is x squared, right? So what is left is basically x squared. X squared. So the final answer is 5/2. Let me pull that x squared out too. 3 natural log of x plus 1. That is the final answer. Okay. How about this? The last example on this page is find y prime if y equals to the natural log of x squared times root under 1 minus x. Let us simplify this. So here, before I found the derivative, before I differentiate, here I differentiate, right? Before I do that, I simplify it and then write in the simple form. I want to do the same thing here. Okay, how do I do that? Basically what I want to do here is y is given as natural log of x squared times root under 1 minus x. Can we simplify this? I want to use the property number 1. If there is a product, I can simplify this. I can write in the sum form, right? So I want to write natural log of x squared plus natural log of 1 minus x to the 1/2. That's what I want to do. Okay, so this can be written as 2 natural log of x. You have seen all this kind of simplification in college algebra, right? And then plus 1/2 natural log of 1 minus x. Now I want to find the derivative. So let's differentiate on both sides. If you differentiate, what do you get? This can be written as y prime is equals to 2. What is the derivative of natural log of x? 1 over x plus, since this is a number, I can pull that out and find the derivative of natural log of x only. Similarly here, 1/2 is pulled out. It is like the derivative of, this is like u, right? So what is the derivative of natural log of u? So it will be 1 over u times u prime. You see that? So it will be 2 times 1 is 2 over x plus 1/2 times 1 over u is 1 minus x, right? Times, what is u prime? This is basically u. What is the u prime is 0 minus 1, right? So that will be -1. So the final answer look like 2 over x minus, because 2 times 1 times 1 times -1 is -1 over 2 times 1 minus x. That is the final answer for this example. Okay, so we'll see a couple more examples in the next slide or next page. Okay, let us look at this example, because so logarithm makes the problem very easy to find out the derivative. Okay, sometimes if you have to use the quotient rule or the product rule for the complicated type of problem, then you can use the log, you can take log on both sides. For example, look at this. If you have to use the quotient rule, it has a root and then quotient inside, right? So it will be complicated. But if you take a log on both sides, it will be easy problem. Let's take a log, okay? So let us do that, this problem. So it will be take log, okay? Take natural log, ln on both sides. Both sides. What do you get? You will get natural log of y is equals to natural log of root under 1 plus x squared over 1 minus x. I took natural log on both sides to make this easy to find the derivative. I have not found the derivative yet. I want to simplify this first, okay? So this is basically, you can write natural log of 1 plus x squared over 1 minus x square and then to the 1/2, because the root means to the 1/2. But in the log, that 1/2, that exponent goes to the front, right? So this can be written as natural log of y equals to 1/2 natural log 1 plus x square divided by 1 minus x, not x square. This is 1 minus x, okay? This is just 1 minus x. Okay, now, but in this quotient, I can break this into 1/2 natural log of 1 plus x square, right? Let's write on bracket there, minus natural log of 1 minus x. Now it is easy to find out the derivative of this thing, right? Because the derivative of natural log is just 1 over u times u prime. Natural log of u is 1 over u times u prime. So let's find out the derivative. Differentiate. What do you get? What is the derivative of that? You can write natural d ln y over dx, right? Equals to the derivative of these things. You can write 1/2, and then if you want to, you can write d and then ln 1 plus x square over dx, right? And then minus d ln 1 minus x over dx. I just wrote that step. You can basically skip this step, okay? Now look at this. They don't match, right? There is y, there is x. Similarly, here is natural log of, this is like a u, right? And similarly, here is, this is like a u. Natural log of u over dx. Let's write on v, because I don't want to use same u there. So v, this is v, okay? Let's find out the derivative there. So what do you get? You get basically 1, this is 1 over y times the y prime, right? That is basically because you want to find out y prime. So that's the y prime. So you'll have to multiply by y on both sides. So 1 over 2, what is that? 1 over u times the u prime minus 1 over v times the v prime, right? Because natural log of v, the derivative of natural log of v, here is the derivative of natural log of u. And they don't match. There is u, there is x. There is v, there is x. They don't match. That's why we use that formula, right? So how much is that? 1/2. What is 1 over u is? 1 over 1 plus x squared times, what is u prime? The derivative of 1 plus x squared is just 2x, right? Because 0 plus 2x minus 1 over 1 minus x times, what is the derivative of 1 minus x is -1, right? Because 0 minus 1, -1. So let us write down that form. So how much would that be? Let me multiply by both sides by y as well. I want to multiply both sides by y as well, because and then simplify that, because I want to solve for that, will cancel out, right? So basically you get y prime equals to 1/2, right? That will be 2x over 1 plus x squared, and then plus, because -1 times +1 is -1 times -1 is +1, divided by 1 minus x. And let me plug in the value of y as well. Y was root under 1 plus x squared over 1 minus x. This is the final answer, okay? So that is the basically final answer. Let us look at the another similar problem there, okay? So what it says is find f prime of x if fx is equals to natural log of x plus root under 2 minus x squared. You'll have to change rule multiple times here. Chain rule, okay? So how do I do that? Let's see. So let's find out the derivative. Differentiate. You will get f prime of x is equals to, here is d over dx, and the natural log of, basically you can think this as basically u, right? This is like a u. The whole thing is like u. Natural log of u. So what is the formula for that? This is 1 over u times the u prime, right? So what is u? So let's write down that as 1 over x plus root under 2 minus x squared, right? Times u prime is the derivative of that. Let me write down that x plus, let me write down 2 minus x squared to the 1/2. There is a prime. This derivative is for everything, right? So since this is plus, you can write, you know that f plus g prime can be written as f prime plus g prime, and if there is minus, you can write that too. So I can distribute that prime for the plus, okay? So this can be written as 1 over x plus root under 2 minus x squared. You see that? Times the derivative of x is 1 plus, look at this. This is derivative of 2 minus x squared to the 1/2. You cannot distribute this 1/2. So what you need to do is you can think this as u. So u to the 1/2, right? What is the formula for that? Is 1/2 times u to the 1/2 minus 1, right? Times u prime. Again, that is another u. So that u is different, okay? Now I assume that as another u. Or you can take this as v, that is perfectly fine. That is the derivative. So I found what I did basically here, if you want to write that, you can write this like this. X prime and then plus 2 minus x squared to the 1/2 and then prime of that. It is like f plus g, right? And I took this as I took that as u. And I use that formula, okay? So how much would that be then? So it is 1 over x and then plus, right? And then 2 minus x squared, right? And then times, let's simplify that, 1 plus 1 over 2 times, what is u to the 1/2 minus 1 is u to the negative 1/2. So I'm going to write this as root u, because I move that to the bottom, will be u to the positive 1/2. U to the positive 1/2 is basically root u. And what is u prime? U is 2 minus x squared. So u prime will be 0 minus 2x, right? That is u prime. So the very final answer would be 1 over x plus root under 2 minus x squared, right? And then times 1 plus. How much is that? Oh, by the way, this will be minus, right? Because 0 minus 2x. 0 minus 2x there is negative 2x, right? So negative 2x over negative 2x over 2 times root under, what is u? 2 minus x squared, right? Oh, by the way, you can do one more step. You can cancel that and find out, write the final answer like this. 1 over x plus root under 2 minus x squared, right? And then times 1 minus x over root under 2 minus x squared. So you can write the final answer in this form. So very last example for this section is find the equation of tangent line. So tangent line means basically you need y minus y1 equals to m x minus x1. This is the equation of tangent line. Okay, so this is like x1, y1, but we don't have m. M is the derivative. So you will find out the derivative and plug in that point. That will be the m, okay? So solution is, so what is f prime of x is basically 1/2. Oh, by the way, look at this. You can pull this 4 to the, since this x to the 4, this is x to the 4, you can pull that to the front, right? So it will be like times, by the way, let me write down fx for one time and then I'll find out the f prime later, okay? So I'm just copying that but writing in the simplified form. F1/2 times 4 times x and then ln x. You can pull that 4 here first and then move that to the front, right? X times ln x. So you can write this as, so if you divide by 2, you'll get 2, right? So it is like 2x ln x. You see that? So 2x times ln x. So let's find out f prime of x. So 2 is just a constant, you can pull that out and then just do the, it is like, you can think this as like f times the g, right? So what is the derivative of f times g? It is f prime is 1 times g is natural log of x plus f is x times the derivative of g is 1 over x. So what do you get? It is basically 2 times natural log of x times 1 is natural log of x plus 1. Because x and x will cancel out again, you see that? This will cancel out with that x. Okay, so, but you need to find out at negative 1 comma 0. Oh, by the way, this cannot be negative 1 because you cannot plug in that. So let us make it positive 1 comma 0, okay? Positive 1 comma 0, not negative 1. It must be positive 1 comma 0. Yes, let's make it positive 1 comma 0. So this will be basically, so this will be, let us make that positive 1 comma 0, okay? Or I mean, if it is negative 1 2, what you could write is you could move this these two to here, and then write natural log of x square, and then put -1, and -1 square will be +1, so that will be 0. So I mean, it is okay if you write -1 here. Okay, if it is -1, you will have to plug in that -1, but that 2 will go to the exponent, so that will be +1 actually. Okay, so at 1 comma 0, this will become f prime of x, f prime of 1 basically, right? Because x is 1, equals to m equals to 2, and then natural log of 1 plus 1. What is natural log of 1? Natural log of 1 is 0, right? So it will be basically 2 times 0 plus 1 is basically 2. The slope is 2. So what is the equation of tangent line then? So let me write that is tangent line is, just plug in here, y minus 0 equals to 2x minus 1, right? So it will be y equals to 2x minus 2. That's what you will get. That is the final answer for the equation of the tangent line for this problem. Okay guys, thank you.